YouTube canal desteviazolgem YouTube canal destewi kunu daddy. Humanoids just got a layer of skin so sensitive it can detect the weight of a single grain of sand across their entire body. Plus you are about to be able to build one yourself right in your own garage. But what does this mean for the future of fine touch robot abilities when for decades these machines have been learning to walk and talk while lacking the one human sense? That defines our interaction with the world. A wave of advances in robot electronic skin is equipping machines with full-body tactile perception for the first time ever. As humanoid platforms transition from laboratories into real-world settings, the engineering focus is shifting from locomotion towards something more fundamental, which is the ability to feel with even more precision than a human. It all starts with textile-based electronic skin, which is a flexible foldable material with a folding radius of under 2 millimeters that can be tailored to a robot frame like a fitted suit. At the fingertips, high-sensitivity tactile sensors pack dozens of sensing elements per square centimeter, detecting gram-level contact and distinguishing surface textures. This precision now extends across the entire hand, where full palm integrated tactile sensing captures pressure distribution, simultaneously giving robots a complete map of how an object sits in their grasp. This feeds into dynamic grip force monitoring, where real-time feedback allows continuous adjustment like loosening on a paper cup or firming on a metal tool without pre-programmed force limits. Underlying all of it is high-precision pressure calibration, ensuring accurate readings across a wide range of forces for robots to be able to handle anything from surgical instruments to industrial parts. But sensitivity does not stop at solid contact, because airflow dynamic sensing now detects forces as subtle as 0.01 N, which is fine enough to register a light current of air across the sensor surface. When it comes to its hands, they are not just sensing, they are also communicating, because full palm pose teleoperation translates a human operator hand shape and finger positions onto a robotic hand in real time. This enables intuitive remote control as well as knuckle angle tracking, which captures the bend of each individual joint, providing the motion data needed to replicate the full range of human hand articulation. This technology has already moved beyond the lab, and manufacturers have begun custom production and mass manufacturing of the electronic skin system, scaling from prototype to commercial supply, with the global market for flexible sensors being projected to reach billions of dollars by the end of this decade. What is emerging here is a generation of robots that can perceive the world through sustained physical contact. And these are machines that can feel a handshake, or catch a slipping glass, or even sense the people around them. But what if you could build a robot that could wear that skin? Because Menllo Research has just open-sourced its Azimov, which is an agent-native humanoid robot available as a DIY kit, now open for pre-orders at a target price of just $15,000. Named after Isaac Asimov, the science fiction author whose 3 laws of robotics remain a foundational framework for safe machine behavior, the robot is designed to augment human capability rather than replace it. Azimov runs on the Menllo OS stack, which integrates 5 components, including Menllo OS for the agent abstraction layer and the agent platform to deploy AI agents with safety guarantees. It also uses Uranus to validate behavior in simulation before physical deployment, and Psychoron to train motor skills like locomotion and manipulation, while the data engine captures operational data for continuous improvement. When it comes to the hardware, they are using off-the-shelf parts and 3D printable components with standardized servo interfaces and an integrated perception stack, plus onboard compute for low latency, reflex loops, and hot swappable battery modules. Safety constraints and telemetry are implemented at the hardware level, where every policy passes through safety boundaries before reaching the robot. Rather than vertically integrating manufacturing, Menllo opened Azimov as a reference design for an ecosystem of manufacturing partners, with Menllo OS abstracting away hardware differences. Here is an option for the open-source robot brain, as researchers just open-sourced a framework that lets AI write its own robot control code. The team from Nvidia and UC Berkeley and Stanford and Carnegie Mellon just open-sourced CAPEX, which is a framework for building AI agents that control robots by writing and executing code in real time, rather than relying solely on pre-trained motion policies. CAPEX equips robots with perception APIs and control APIs and auto-synthesized skill libraries, allowing them to solve zero-shot manipulation tasks that learned policies would generally struggle with. The framework includes 4 components, starting with CapGym, which provides 187 manipulation tasks across tabletop and bimanual and mobile settings in both simulation and real-world environments. Then CapBench evaluates 12 frontier models, including Gemini and GPT and Claude, Opus and Quinn and DeepSeek. Next, Cap Agent Zero is a training-free system that matches or exceeds human expert code on 4 out of 7 tasks without specific tuning. Finally, CapRL applies reinforcement learning directly to the coding agent, which is a 7 billion parameter model that jumped from 20% to 72%. Success after just 50 training iterations, with programs transferring to real robots with minimal sim to real gap. This project traces its lineage all the way back to Voyager, which was an agentic AI built 3 years ago by the same team to play and learn continuously in Minecraft, so its core ideas like skill libraries and self-reflection loops and in context planning have now graduated from the game world into physical robotics. While AI is rewriting what is physically possible, Netflix just taught a model to erase objects from video and rewrite physics they left behind. Netflix just open-sourced Void, which stands for Video Object and Interaction Deletion, and it is a new AI framework that removes objects from video footage and automatically reconstructs how the remaining scene would physically behave without them. If you remove a person holding a guitar, then the guitar falls, or if you remove a car from a collision, then the debris and smoke and impact disappear with it. Void was made possible by building on top of Alibaba Cognidex, which is fine-tuned with synthetic data from Google Kubrick and Adobe Humanoid. Google Gemini Pro analyzes each scene to identify afflicted areas, while Meta SAM to segments the objects for removal. Finally, researchers just wove artificial muscles directly into fabric using electrofluidic fiber muscles. These are artificial muscle fibers that can be woven directly into garments, being 2 millimeters thick and using integrated millimeter scale pumps to move fluid through a closed circuit, eliminating bulky compressors. The result is silent vibration-free actuation at a power density comparable to the human skeletal muscles. In demonstrations, a bundled fiber lifted for kilograms or 200 times its own weight, while a woven muscle bent a robotic arm 40 degrees yet remained compliant enough for a handshake. Their performance scales by adjusting the ratio of pumps to actuators, and this was all published in Science Robotics in 2026, with the work positioning these fibers as a foundation for consumer wearables as well as soft robotics that are powerful and portable and potentially machine washable. As your guide in this journey, I have to tell you that successful content creation on YouTube requires more than just knowing the tech, because you need to understand your target audience and their sociological structure to make your videos truly resonate. To reach more subscribers and watch time, you must maintain a consistent sharing schedule, because inconsistent content causes you to lose viewer interest. Your thumbnails should never be clickbait, but instead they must accurately reflect the content while remaining highly attractive and professional. Use tools to optimize your titles and descriptions with keywords so the YouTube algorithm can recommend your videos more effectively. Remember that quality production in both sound and image is the key to keeping your audience long-term. Monitor your channel parameters closely and aim for a click-through rate of at least 5% and ensure at least 50% of your traffic comes from browse features. Success requires patience and consistency, because sometimes even a high-quality video takes time for the algorithm to find its path. So is this the future of robotic muscles, or are we heading toward a world where the line between machine and human vanishes entirely? Comment down below, and do not forget to like and subscribe and click on this video here for more in the latest in AI and robotics news.